Yo, torched. Oh, let's get this one going. Let's get this one over with. It's gonna be a quick one, boys. Beat, beat. Super beat. Super fishy, super freaking. What am I doing? I'm gonna start activating chat. That's what we want to do. You gonna make me hear the melody flow. The air is thick, it's smelling right. You're flying to the right, don't be no quick to walk away. Dance with me. Go! I wanna rock your body. To the birthday. Dance with me. Yo, I think we're good. Alright. You guys know the drill. Leet before bed. You know how it is. Let's get this going. Leet before bed. Leet code. Why is this still caps lock? Yo. Here we go, we're vibing to the groove of the funky tune. Alright. Are we live? What happened to my stuff? Oh, we are live. There's people here. Hello, everybody. Appreciate you guys for being here and hanging out with me. Sorry I'm late, AF. Another long day at work. You know, gotta pay the bills. Getting things ready to go to release some more product tomorrow and the day after. So, things are moving along. Things are going good though. Just busy. Ooh, all right. I appreciate you guys being patient with me. We're probably gonna solve just a leak code problem today and then bow out. And then we'll be back. Honestly, I'm sorry. It is what it is. I have a full-time job, and sometimes I get into these busy spells, and other times I can do double streams. So give and take. So thank you guys so much for obviously your support and everything, and I appreciate you guys for supporting me throughout it. So thank you guys. All right, come on, bless up. Roll the dice. Pause. Medium level tree. Oh gosh. Array tree level order. N array. Given an array. What is an n-array tree? What is this? What is it? Is it n array? What is this? Return the level order traversal of its node values. Nary tree. Okay. Nary tree input serialization represented in their level order traversal. Each group of children is separated by the null value. Oh. So if no is no. Oh gosh. Dude, I don't want, come on. Leet code. Don't do this to me. Don't do this to me. Okay. So we have a class node with the value itself and self.children. never done this one before, right? We've always done just self.next on the node. So we have self.children, which is optionally another list node. Okay. Okay. I'm kind of a little bit confused. So if it's represented in their level order, so we just return the groups, right? Given the root node. Okay, so let's just do some debugging here, right? We have root, right? Let's just print root dot val. Let's well, for one, let's also just print the root, and then let's print root dot children here. And let's do this one more time. Let's call dot children here, right? Let's print and see what this is outputting. Okay. Oh, so just put it, right? We'll say dot val. So we're just getting root, we're just getting node objects, right? List object has no attribute val. Okay. So that is print just children here. What is the outputting? Another node object of a list. So 3 node objects. Okay. Now let's say print what am I getting here? That's the children. So this is a list of 3 node values. I want to print val for val. Boom. Hold on, I want to just. It's gonna give me every node for node and root.children, so we're gonna go, sorry. Node.val for node. And root.children. No one in chat today? Is chat working? Okay, let's just print out a list of values. Sorry, rather than a generator. 3, 2, 4. Okay. One and a list of all the nodes. 3, 2, 4. So you just can't use like none until root.child. It has no next value. Self, value, children. So then you have to go into the children recursively. Okay, right? Okay, so let's write a function here called like def parse children. Right? We're going to say if def parse children given a node, right? This caps lock key is so annoying. I got it. Right, given the node, we're going to say if, okay, we'll say children is equal to node dot children, right? If children is none, children is none, right? We're going to just but we don't want to get okay, so then if node is okay, yeah, so we're going to say parse children. Children equals to node dot children. If the children is none, meaning we don't have any more, we're going to return right in our base case. What do we want to return? Anything? Do we want to return the value? If it's none, we want to just stop, right? Else what we're going to do is we're going to take the children. We're going to say for, so in this example here, we're on the 1. We're going to call parse children on this guy. It's going to say, is children none? No. Has children. So we're going to say, okay, for every child and children. We're going to first append this value, right? We're going to say, okay, so result equals to a list, right? Oh, but then you have to get all the values. So you get the node itself, and you get all the children. Yeah, so we gotta go like this. We have to for, well, first we need to so if I append the value, I'm on the 1. Alright, I'm on this, I'm just on the 1. Okay, now what do I want to do? Obviously I need to save the 1 into the result. Okay. Right. for child in children, we're going to result, well, first we're going to just append. Oh, I'm tired, you guys, I'm gonna be honest. Oh. Okay, so we know we're getting a list of children, so let's just look at this first example here. If we're on this one, and I want to obviously have the output be 1, and then all the children, and then those 2 children. So I have to obtain all of the, I have to kind of go row by row, right? So how can I set this up to where I can accept the value that we go on to, right? So we say, okay, we parse this node, we go on to this value, we say, okay, is the children none? No, there has children, right? So we need to call parse children on all of the children, right? Which will run and then return back to us at the end, and then that'll append values at the end here. So if we say children is none, we want to take the current node that we're on. Return, right? The result, we'll check, parse children on child, right? This is just going to go through and they say get all these children and go to the end. It's not really what I'm wanting to do here. Interesting, because I'm wanting to take this value, I want to parse all of the children, which I can get by just calling this. You're only going to call it on a valid node. So if the node doesn't have any children left, then we're going to be done. Right? So the parse children function, after we call it, we pause and wait for this to go through. And it's going to return back to its child what? Nothing in this case, because we need to be new comparison. So if we just say child dot right? And then if we say result append this, right, this will go through and append all the children to it, but we need to get, but then all the other children will go. Like, what if there's other children that it's here in this example, like if this goes all of those children, okay, well now it's going to start appending all of these values and those values, but we want to append all of these values together. That doesn't work. So if I want to append chat's working. It's not working. My social stream closed. Oh my bad. Chat's been off this whole time, bro. Yeah, you guys know I'm tired. Oh my gosh, I'm trolling. Oh my gosh, I'm really sorry, you guys. I thought no one was here because it was late. I need like a soundboard, like a bruh.
Morphe says, so chat back up?
Chat back up. Yeah, let me load up chat real quick.
Morphe says, good morning everyone equals D.
Oh, I'm so tired, man. I've been at work all day. I got home like 45 minutes ago and ate some food and took my dog out. I've been in the lab all day.
It's 6:50 in the morning here.
Wait, hold on. Let me go to my chat. What happened? I'm confused. Where did I just go to see chat? Oh. Here we go. And then let's go. Okay, now I can see chat. Okay, so hey, Stately Fall, what's up, man? How's it going? I appreciate you being here. You think I'm pretty close to solving the problem? I don't know. I thought I was kind of failing there. Should I go back, bring my code back? Hey, Norpie, thanks so much for joining me. You're 6:50 in the morning. Jeez, early bird. All right, we're caught up on YouTube chat. I mean, Twitch chat. Kogo, what's going on? Sorry, guys. I appreciate you coming in here. Anand, how's it going? Axel, how are you, my guy? Charlie, what's up, Chief? Hey, Jessen. Level order. Hey, Sucks, how's it going? Hey, Alexander Jacobson, how's it going? I appreciate you coming in. Anon, welcome back in, my guy. Justin, like always. I would say enjoy outside, finding a job. Michael, I was coding, but I took a huge break. Should I get back going or give it up? Get back going if you want to code. Do whatever you want to do.
Sucks says, how can I remember code muscle memory for doing it more? Jessen says, sucks. Exactly. The key is just doing it. You have to fail to learn. Sucks says K. Sucks says, Seems like I am underestimating my brain. Sucks says lol. Sucks says W Michael.
Yeah, just a lot of people just kind of sit there and like question, oh, should I do it or should I not do it? Should I start just code? Just like sit down and just put 30 minutes on the clock and yeah, it might be hard at first, but then like after a while 30 minutes goes by pretty quickly, and then you can sit and do an hour, and then 2 hours, and then 3 hours, and then I mean once you get into a project that you really like, you'll find that time really is kind of like nothing, because you were like wanting to do it. Okay, so we're trying to get level order right, but we need to understand we need to wait till, okay, so this will call, so we need to have it return back to us. Okay, so if we parse children, right, and then we say, okay, let's say if node.children is none, right, and then let's just, I don't know what we're gonna have to do here, but so do I want to go one by add first, second, third, fourth, or add from the bottom up and then flip the list? Because I feel like I'm gonna have to return something on my base case in order to capture the values of every node, because the first one
says, what should I learn and how Python, Lua, Roblox, CSS, Java. Jessen says, I just made an autograder program for the online grading department at my university.
Hey, sweet dude.
Sucks says IDK, and do I need to learn HTML first and CSS?
No, I learned Python first. There's tons of stuff you can do with Python. I think Python, you can do pretty much anything you want to do in Python. For the most part. You can make games in Python if you wanted to. Okay, so we have... Let me turn off TTS. What do you think? The first level's not that hard, right? But the second level, once you split off to a completely different branch, right, now we have no actual connection other than this linkage back here, right? There is no connection between 6 and 7 and 8 and 9 and 10 other than the parent. That is their common ancestor, right? So I feel like we have to build from the bottom up. Hey Keep, how's it going? I thought I turned on the other type of chat, the one with the last names. Oh yeah, I do have it on. I think I have it. I think we're okay. This one's 429. Nari. Nary tree. Whatever that is. Okay. So the thing is how can I get access to when I'm on a completely different branch, right? So in the example of like if I say for children, if I am on none, just return, and then do I save that row? So once I return back to that row, if children is none, then we're just going to wait. I guess we'll return. Right, but that'll be over here. So the thing is, I gotta pass these values back all the way up. Oh, I don't know. So, because the thing I'm getting tripped up on is when when I diverge from like the 3 and the 5 or 3 and the 4, I start to go on a completely different. The only relation I have is back to this 1. In this case, we just go, okay, for all children. Since I have another function, right, that says okay, so if it's just children is none, we're not gonna do anything, right? We're not going to do anything. So then what happens if I go like this? Like if I just write a function to just parse the children, right? And return those back, and then I use a for loop outside of that to go over every child. Right. Like if I have node here, right? And I come over here and I call, so if I have a node here, I come over here. So if I have, if I have a node and I take a parse children, okay, let's say I have 2 children. Oh, yeah, let's say I have 2 children. Let's say I have 3 children, right? If I have an outer for loop that would go through all the children, right? And then call parse children. And then what will that do? That will just go through. No, but so if you could start going over here, let me just go with a binary tree example. So I obviously would start here. Now, this node has children, right? So yes. So do we want to, at this point in time, call the parse children function on it, like for child, and then do a function on the child? Now, what will that function do? Detect if it has children. Well, then it's kind of doing the same thing that we were doing before, which is so we recursively detect. And if it does, we continue to go down and call down there. Where's chapter on trees? Although the pre-order approach or traversal are common ways of visiting positions of a tree, another common approach is to traverse a tree so that we visit all the positions at depth D before we visit a position at depth D plus 1. Such that algorithm is known as a breadth first traversal. A breadth first traversal is a common approach used in software for playing games. A game tree represents the possible choices of moves that might be made by a player computer during a game with the root. One, two, three, four, five, six, seven. Okay. A breadth-first traversal is such a game tree is often performed because a computer may be unable to explore a complete game tree in a limited amount of time, so that computers will be considered all moves, their responses to those moves going as deep as computational time allows. Pseudocode for breadth-first traversal is given in code fragment 8.14. Okay, so there's some pseudocode. So we want to initialize QQ. Is it with the Q? Contain the root. While there is no in, we're going to pop off the value DQ. For each. Oh. Okay, so interesting. Look right here, you guys. This is pretty cool, interesting. So what it's saying is that you initialize this queue, which we'll say is our list, right? So we initialize a queue around our item here, right? Now for this specific queue, right, we're going to dequeue whatever's in it, right? So we're going to dequeue this because we need to and then we're going to perform an evaluation on that. This is basically all the rows, values in each row we're going to dequeue and then get all of its children one at a time, something like so. Then like for each child in the tree.root, children do the add the positions children to the end of the queue for later visits. I think this is the right way to go here. Looks like some other people agree here in chat. Hey Ray, a lot of people chatting tonight. Holy crap, there's tons of people in here. If you guys are in here, leave a like. Appreciate you guys being here. Smash a like for we came in here and after a late night stream. or late night. It's a late night stream because we're late coming on here. Okay, so let's think. So I want to do something similar to my pseudocode here. Right. So if where's my OBS? There we go. We're back on chat. Yeah, I'm drawing on my mouse. So for those that are asking about learning resources, I have a Discord link down below with my entire roadmap for learning resources. Every book I've read, I provide to you guys as a PDF copy with my personal notes as I read through the book so far. Python Crash Course, Fluent Python, Data Structures and Algorithms in Python. As you see, I just pulled this book up because I remembered this section from our reading live, so I wanted to go back and reference it. And remember, right, we read this a long time ago, and I've never actually done a BF, breadth first search, so this is kind of interesting that we're kind of so long ago we learned about it, but we never actually put it into practice. Yeah, so in my Discord link down below, completely for free for you guys. Also, community projects, project showcase where you can get see my projects, weekly breakdowns of the Harvard CS50X course. I took that course live on stream at the beginning of the year, and I have a breakdown of it in my Discord. And then yeah, lots of cool stuff in there. Okay, so we want to initialize a queue to contain the value. Okay, so let me move the Leet code over here so you guys can see.
Jessen says, BFS is definitely the way I would go for this problem.
Okay, so if I parse children here, so I say we want to initialize a queue to contain the values, right? Within this algorithm. Oh, but this isn't recursive. This is iterative, right?
Samet Ju says hi.
So we want to do this. Oh, so they didn't talk about this recursively. This is iteratively. So then just add stuff back to the queue to be dequeued.
Keep says bro Mike.
Bro Mike, how's it going? Okay, let's
Keep says, where do you get this playlist?
It's just I think it's on it. I think it's AI.
Which Leet code number is this one?
I think it's AI. It's just it's like there's tons of like these recent pop-ups of people just using like AI art and AI like music to, and then I don't know. YouTube doesn't like done anything to update their policy on AI music and copyright, so it's kind of like a little bit of a loophole right now. I'm not sure. Knock on wood.
Sucks says, guys, I got VS Code. Samet Ju says,
this is 429.
And I am coding my first AI. If you want to check
so
it out
I'm gonna look
after
up
it's on my Chanel, you can go after lib if you want.
Breadth first.
Samet Ju says that's not an ad XD. Sucks says congrats Sam.
Breadth first searches and graph traverse algorithm that explores a graph level. I don't want to look at media AI.
Keeps as nice.
Given an undirected graph represented by JSON.
Sucks says Sam I sub. Sucks says keep going. Sam at Ju says, sucks thanks.
What? So they still use a queue. Okay, should we try it with the queue then? Like they do in Python? Right, you import queue that way, right? Oh, it's deck. So if we, I want to do this recursively, but whatever. So if we have our function here, level order, right, we're going to say, Q is equal to our deck. Do we have to call this? Like, do you have to call deck? I forgot. I haven't used this in a long time. What do they ever call it? Deck. No. Oh, here you go. They just do, yeah, you do have to call it here. So if we say Q is equal to a deck, we say right, while Q current is equal to, I'll say parent is equal to Q dot DQ, right? And then we're going to, for child in parent.children. Well, I need to initialize the queue, and then I need to have it contain the current node, right? So you say q dot is it at? We'll find out. We'll add the root and while queue. We'll take the child. And then we want to perform a revisit action for every position, right? But the thing is before we do this, we want to take a current screenshot of the queue, right? So if I convert list I mean, is it already like a type list, or is it like a special type? Oh. I didn't think of the hardest problem. Not hard, but I don't want to do this right now. I want to go to bed. So we have, obviously, so if I say, let me do this. Let me print just the Q. Right, I know we have errors, but we'll just see what it. I mean, what is it? Oh, add. Deck has no attribute add. It's just a pen. It's an idiot. So it is a list. Okay. Trolling, dude. Tired, man. Okay, so you get a deck object. Now, if you call, does deck support the stir? Okay. So I add it, and I need to take a screenshot basically of what my queue looks like before I start popping parents out, right? So at this print statement here, I need to take a screenshot. So if I print list queue here, right? What does that do? Just wraps the node in it. Oh, so it's just, okay, so it shows me the list of the node itself. Okay, cool. But I don't need a list of the node. Right, I need a list of the node's values. So I guess I'd have to go like this, like, if I say result is equal to an array and say result.append child.value for child in node.value for node in queue. If I move on though, I'm gonna lose. Right, then we're gonna add the child. The child here, no? I don't know. Oh. 1, 2, 4, 2, 4, 5, 6, 5, 6, 5, 6, 6. Interesting. Just then use a for loop to use each item in the queue. Hey Daniel, what's up? PhD student here, also needs to learn Python eventually. Nice, I appreciate you, Daniel. Lots of chats, you guys are chatting it up here. You guys are awesome. If you guys are here, leave a like. Really, really helps to keep the stream going, and consider subbing along here. Okay, so we have a queue. I'm going to append a list of all the values for every node that's currently in the queue. And then I'm going to go through. No, I don't want to do this. Oh, because I need to. Okay, so I'm getting some circular going here, right? This is going. Right, because I'm adding stuff to the end of the queue and then popping left values, and so the while loop is going until, and so there's no distinguishing between some of the parents and some of the children that get added on to the end of the queue, basically. Oh, crap. So if we append if res index of -1 index of -1, hear me out. If the res result index of -1, so the last value in last list in there, and the last value in that list, if that node, well, that we're actually just doing values, right? So what if I throw like a What if I throw append, what if I do this? Q.append, like none here? Right, what if I append the none at the end of every child, at the every child loop for each parent pop off? Because then it's going to add all 3 of its children to the end of the queue. So what's happening is like, I'm getting the node here, I'm adding it to the queue, and I'm going through its children, I'm adding 3, 2, 1 to the queue, and I have 1, 3, 2, 1, no, 4, sorry. But I popped off, now I have 3, and I add its children, 5 and 6 to the queue. Now I keep popping. Okay, so trying to form crappy AI ads on YouTube.
Today, I'm going to teach you breadth first search. I want 2 things to come to mind. So let's use the following graph, which is a collection of vertices and edges. We want to know all the nodes that are discoverable from the root node, A. Along the way, we'll keep track of 2 things. First, nodes we visited will be colored black. Nodes that are in the queue that are in line to be visited will be colored gray. Starting our algorithm, A is the first node we'll visit. We'll keep track of the queue in the top left corner. We pop A from the queue and mark it as visited. We also add its adjacent nodes into the queue. B is the next node out of the queue. We mark it as visited and add its adjacent nodes into the queue.
So right now that I'm capturing a screenshot there, and I'm not supposed to. I need to get the C out of there and then capture a screenshot.
Same with C. Example in the description.
So say, wow. Let's do this, I guess. So I want to use lists here, or go back to my deck. So I want to be able to pop left, not insert left. It's already 10:30. I gotta go to bed. I got work tomorrow early. Again, another long day. So let's import. And let's do a deck. And let's do They added hinting on Leet code? Since when? They didn't have this before. They added syntax highlighting? Apparent in visited. No, not apparent and visited. We want to check. So we want to check if the. So while we have Q, when we have a Q, we want to get the parent, and then after we add every child. We're going to add to the visited. Now, how can I distinguish the when to stop? Can I add a none? That's like a cheat, right? No? Can I add like a delimiter, basically? Can I say right, for child in parent.children, we're going to q.append child, right? And then at the end of the loop, but that's just gonna do no, so that's just gonna, that one's current children. So what if I add these? For every child, we're going to append the child onto the queue. How can I take a screenshot of the values of each node before I keep going here? Like, I need to somehow detect, right? So if I pop off a parent, I put it into visited. If I give a child then if we add right, we add the parent at the end of adding all the children to the end of the queue. Then if any, like, if any of the child's parents in this one's 429. Over a list. Pop. If it's not, so we're going for every child, right, in the parent. If the parent is not in visited, or if the child is not in visited, why would the child be in visited?
We iterate through in the queue. And if the node has not yet been visited, we add it both to the visited list and the queue.
All right. I'm going to bed. I'm tired. I worked all day today. For those that don't know, I'm a chemist. I have a degree in human biology and a minor in chemistry, and I teach myself how to code afterwards. And I've been releasing my product that I've been working on for a while. I've been putting in some long. I've worked all day, like pretty much 8 to 8 almost. So I appreciate you guys being here and hanging out with me. I just wanted to come on here for a little bit and try to solve one of these, but I'm too tired. I can't even think. Like, I'm tired. I got to do some more research on more tree traversal algorithms. I honestly don't know a lot about them. I kind of avoided them. Anyways, I'll see you guys tomorrow. I should be on the normal time tomorrow. I believe I'll be back. I set things. I put in a lot of work in today's to where I'll be able to be a little more smooth tomorrow. But thank you guys so much for hanging out with me today. Tomorrow we'll be working on our project Stalker, which is currently just a stock portfolio viewer where you can currently access. You can load in. I have to style this page, right? But you currently can. The idea is that you can view all of your accounts across many different. In one portfolio, right? So if you have like a Roth IRA or a 401k or an individual taxable account, you can sync them all up within one portfolio and view them all. So we have this accounts page with the all accounts view here, and then you can select individual accounts within the portfolio, and you can see that our 1 share of Apple and 1 share of Microsoft, 10 shares of Microsoft that we got for free here with the test dummies here have brought us in some nice total value and unrealized gain because obviously it's been free. And then we have a Roth IRA, you can view that one. And then we have this add position button that will pop up. You can add a position here too, and I need to add the functionality to here though. But we'll work on this tomorrow. Then I also have the ability here, like with an individual taxable, I'll search this one. You can search for specific headings, right? So I can say I want to search for all positions with asset value that are greater than, let's say, 5,000, right? So this should filter out Apple, right? Boom, Apple's gone. There it is. Microsoft's there. So we have a cool little filter here too, which is pretty nice. So yeah, thank you guys so much for hanging out with me here. We'll be doing more work on this. This is a community project, so if you want to participate and write code for it, I do highly suggest you do. It's access it within my Discord down below for free. And I will say that all the code you write does have to be written by yourself, or not like by yourself. You can use friends and stuff, but I'm talking like by you. The copying and pasting code from AI is not allowed. I don't care if you use AI to help you learn and to gain new insights on new concepts like I do. I do that every single stream. Right? It's a good learning resource tool to learn more about new things I don't know about. But the code we like writing our own code here. So thank you guys so much for being here, and I appreciate you joining me. I'll see you guys tomorrow. Have a good one. I'm Michael. Have a good night, guys. Bye. I'm tired. Boom, 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 boom.